No, the domain for this graph. How do we do the domain? Well, the denominator equals 0, right? Okay, that's what's going to be. Can you solve x squared plus 1 equals 0? No, you cannot. So my domain is going to be anything. Whoops. Did that. Excuse yourself. All right, we're not going to. Let's keep going then. Intercepts. I'm going to have 0, 0. It's going to be my point on the graph. Now, Noah was asking about is every point 0, 0? No, it's not. It just happens for this one. If I sub a 0 in for x, I'm going to get a 0 in for y. It just happens to be that way. Asymptotes. Oh. We're looking for anything in the denominator that equals 0 because you can't divide by 0, right? So in this case, x squared plus, if you're solving x squared plus 1 can't be 0. That means x squared can't be negative 1, which you can't solve, right? Which means any value is correct. Asymptotes. Now, somebody was saying they don't understand how to. We're going back to limits here for a second. Go ahead. Top is x-intercept and the bottom is the asymptote. Yeah. Okay, as far as the asymptote though, for this one, it's going to be a horizontal asymptote. And I'm just going to go through it quickly. The limit as x approaches infinity of 5x all over x squared plus 1. Now, you guys hopefully in grade advanced functions, did anyone do this with limits and advanced functions? Nobody did this with limits and advanced functions? We're in calculus, so we use limits. How do we use an infinity limit? Someone think back to February? No one remembers this. Oh God, I wonder why you have to do that. Well, you divide through by the highest thing in the denominator. Coming back a little bit, at least for one person. Okay, so that equals then 5 over infinity all over 1 plus 1 over infinity, which equals 0 over 1, which equals 0. Okay. So as you go to infinity, the graph is going to be heading towards 0. Is what it's going to be. 0 plus, if you want to call it that, it's going to be positive. Okay, so those are above. Does this come back at all, Tanner, from February a little bit, I hope? A little bit. Okay, so all we're doing for this is, I should write this through, divide through. By highest power denominator. Okay, so we're going to do the same thing for negative infinity of 5x all over x squared plus 1 equals the limit of x approaches negative infinity. 5 over x all over 1 plus 1 over x squared, which equals 0 over 1, which equals 0. Okay, I'm going to hit pause in the video and you guys are going to find some derivatives for me. We'll solve them together as a class, but if we know that f of x is equal to, I should write critical numbers on there first. F of x equals 5x all over x squared plus 1. I'm going to pause in the video, give you 2 minutes to find 2 derivatives for me. Pause, hopefully. Oh. Rather than insult Mr. Sadler, let's continue. with this question, please. F prime of x, I'll do this one as quickly as I can here. Equals 5 bracket x squared plus 1 minus 2x. Hey guys, stop please. Hopefully that's what you got, negative 5x squared plus 5. We can factor that and solve that one. I'm just going to leave that for right now, only because when I take my second derivative, it's easier to use this form. Okay, but yes, you definitely can factor. It'll work out beautifully for the roots, okay? Did most people get that far? Austin, cool? Sort of? Okay. F double prime of x is going to be a little more complicated. Which equals negative 10x times x squared plus 1 squared minus 2 x squared plus 1 times 2x times negative 5x squared plus 5. Yeah.
Minus 2x. Wait, it's actually something.
The derivative of this. Right, minus 2 times x squared plus 1 and times the derivative of the bracket, I think. Ask away whatever that was. So just,
I'm just saying, should it be minus 2x?
no, because what happens is the 2 comes down first, right?
Yeah.
So for chain rule, and then the derivative of x squared plus 1 is 2x. So that comes down after. Right, because like the derivative of the brackets then is that. Okay, let's do some common factors. That's going to be negative 10, negative 10x, and x squared plus 1. Is that right? Did anyone get this far yet, other than me? I did 10 because there's a 5 you can come out here as well. That's why I took out 10. Yeah, I made a mistake, go ahead.
I don't understand how you got access. Like, why is it plus 2?
Okay, let's do it a different way then. So you guys all do negative 2 you took out? Everyone took out negative 2? Negative 2x? Let's do negative 2x then. So it's going to be negative 2x, x squared plus 1. And we'll be left with then 5 x squared plus 1. Hold on a sec, just wait. Just wait. Plus 2 bracket negative 5x squared plus 5, is that right? Does that match now? Does that match now, finally? Okay. I'm going to take out a 5 now. Okay. Is you guys okay if I take out a 5 at this point?
I don't know about that.
I'm going to. Yeah, if you want to.
Right.
Yeah, go ahead. Yes, this one on the left-hand side. Yeah, I'm going to. So it's going to be negative 10x bracket, x squared plus 1 minus 2x squared plus 2.
It's close. Clock's right twice a day. No way. More than me. I'm only right once a day. Not in this class, that's for sure.
Okay. Okay, hopefully that matches what you guys did there. Yeah, go ahead.
And the second one,
Okay, guys, listen up. Listen up, please. So what I did was I factored -2, so that one was gone. Okay? I factored an x, so that was gone. So I'm just left with 2. And then I factored x squared plus 1. Okay, now you might say, Mr. Sal, that seems like an awful lot of work. What was the purpose of doing all that? What can I easily do now? Well, we're finding zeros, right? So if you take a look now, you can very easily solve this equation. I'm going to make both these go down a little bit. So all I have to do when I do this both in red, I just have to solve 0 equals negative 5x squared plus 5. And here I have to solve 0 equals negative 10x negative x squared plus 3. Now I know what you're saying. You're saying, Mr. Sal, that looks difficult. I'll deal with that in a sec, okay? Are we okay with sort of what I'm doing right here for the solving? Can you scroll it? Oh, sorry. Yeah. Sorry, I got too excited there. Sorry about that. Okay, so I'm going to call this 5x squared equals 5, x squared equals 1, x equals plus or minus 1. Now, I didn't take off marks on this on the last test, but on the first one, people did square roots without doing the plus or minus. And I left it as full marks, but I wrote a plus or minus on the front. It wasn't just you. There was probably about 10 people in the class that did that. But remember, if you take the square root of something, there's 2 answers, the plus and the minus. All right. I'm going to do the same thing with this one. Can I scroll down, Jason? Is that okay? So it's going to be then over here we're going to have x equals 0. And over here we're going to have negative x squared plus 3 equals 0. So 3 equals x squared, x equals plus or minus the root of 3. So we're going to have 3 turning points, sorry, two critical points and 3 points of concavity. Okay. Please ask and be brave at this moment if there's a question. Yes? Okay, so what I did was, a 5 can come over here, right? And a 5 can come over here. So 5 and 5 just comes out 3 times. Now, I'm going to be kind to you guys and save some time. Please don't be playing chess in my class. It's a math class. I'm going to be kind to you guys and save you some time and tell you what the points are. So I found for you guys, go over here, whoops, scroll that down. I found f of 0 is equal to 0. I found f of negative root 3 is equal to negative 2.2. I found f of root 3 is equal to negative or positive 2.2. I found f of 1 equals 2.5, and I found f of negative 1 is negative 2.5. All right. We're going to graph this right now in a sec. Now, let me say this. These graphs aren't always easy. So I would strongly recommend tonight, Brad and everyone else in the class, sorry, Brad, just that this is where I look always. I'm sorry. I'm not implying you don't do your homework, but I'm saying that it's time to try this tonight, because this stuff, it's easy to follow along with me, but you gotta do it a few times to make sure. Do those two graphs tonight, I'm gonna finish the interval chart, and then we're gonna graph this one up, okay? And you'll see how awesome this graph looks. So I'm gonna do my intervals. All my intervals are listed right here. So I'm gonna start with x is less than negative root 3. Negative root 3 is less than x, is less than negative 1. Negative 1 is less than x is less than 0. 0 is less than x is less than 1. 1 is less than x is less than root 3. And x is greater than root 3. Then we're going to have f prime of x, f double prime of x, and then your shape. And just so you guys have it, I should probably write the equations out for you. F prime of x was equal to 5 minus 5x squared all over x squared plus 1 squared, is that right? And f double prime of x was equal to negative 10x negative x squared plus 3 all over x squared plus 1 cubed. All right, ready to start subbing values in, and then we're done? Very good. I'll make sure that you'll be getting your choice assignments back. The last one's probably the next, hopefully tomorrow. You'll get your new assignment on Thursday. Okay, there will be probably 2 of these graphs on your assignment. I'd recommend doing them to make sure you know what to do, right? So here we go. Let's pick negative 5. Negative 5 squared is 25, so it's going to be a positive, and a positive, this is going to be a plus. Negative 25, that's going to be a negative, and a plus is a negative, and a negative, which makes it also a plus. My chart matches. Did I get those right? Try again here. Let's try those again here. And that's me doing that at 100 miles an hour, okay? To save time. So what you do to finish up here then, we're just going to plot those points given at the top, connect the dots. Critical point is going to be the local max or local min. That's a critical point. So that's when f prime of x is equal to 0. That's a critical point. Yes. Now I cheated on this one to make it a little faster than usual, because what I did was I gave you this right-hand board. Just take a little bit of time to fill in. Okay. Let's finish this graph and then we're done. Okay, so to graph this, most of the fun stuff happens I got to get my x values from negative root 3. I get down to negative 2.5. So there's 0, there's 1, there's 2, there's 3. And maybe just this is a good time to just talk about graphing. On your choice assignments, I'm going to borrow Luke's note for a sec. Okay, so Luke I love Luke. Sorry, I hope you don't mind. I told the whole class that. Luke has been my student for 4 years. Okay, so he knows that on his assignment, he did his graph in his notes like this, and that's okay. But he knows on his assignment that he has to use graph paper. Okay, right? So do not give me this. You will be losing a mark each time you give me a graph that looks like this. I know you want to fit all your test into one, all your assignment into one piece of paper as small as you can. Make that one piece of graph paper then, okay, that you're going to do your whole assignment on, and that'll be fine.
Jacob Nordeman to the main office. Jacob Nordeman.
So f of 0 is 0. F of root 3, which was 1.7, is 2.2. F of 1 is 2.5. F of negative 1 is negative 2.5. Okay, and then we're just going to connect the dots. Okay, we said we're going over to infinity, to 0 there. And we're going from here to here. Then we're going up like this. And we're going up like this. And then we're going down like this. And we're going down like this. You can imagine how sine and cos graphs are going to work for us. Okay, right? Because that's starting to look like the middle of a sine graph. Right? And that is a pretty darn good looking graph, if you don't mind me saying so. Right, and advanced functions, if they were to give me this, all you'd say is, oh, that crosses at 0, 0, but we don't really know why, and we can't do anything with the outside lines, right? So, yeah. Now, is this tricky? Yes. Okay. I'm going to strongly recommend you actually do the homework tonight for a change. All right. Like I'm going to force you guys to, and actually, I'm looking at you because you're really fun. I'm not implying you don't do your homework. I'm sorry. But no, guys, seriously, make sure you do this. Make sure you do this so tonight. I want to make sure you guys get good at these graphs. Perhaps no. Yes.
So you know what? For the line it says it's approaching 0 quadratic, and it says that it starts to curve back up.
It does. It never actually. It decreases. This is when it as it goes towards 0. It is actually always increasing. Like the slope is going to be 0.001. Point, you know what I mean? Increasing towards 0. Like it's still a negative slope, right? But it's increasing towards 0 infinitely. It's like when you deal. It's like when you deal with like a logarithm graph and stuff like that. They are always increasing. Like it doesn't look like it, right? But it is. It never actually gets to the point of positive slope. All right, there we go. That's all we got for today. Let's see us tomorrow. Tomorrow we're on to word problems. Yay, word problems. Woo.
Just jokes. And I won't be here Friday.
Why are you skipping Friday? I'm going to
No, just like interesting ad running for all the grade 12s to play for their band.
Oh wait, I've only missed one day.
Monday, you don't play in the band, do you?
This morning we got it's not. It's Tuesday. It was Monday. Yesterday felt so long.
Haley, you have 2 minutes to read your book now. I'm sorry I'm called for. I'm sorry. The only thing I'm going to the only thing I'm going to say, Haley, is if you want to make a change, either be an English teacher or marry an English teacher and tell him to give exciting books.
Okay. I don't like being an English teacher. Yeah, no, she's a teacher.
What should I say about it?